Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Safwan bin Shukri. My metric number is 180602. Right now I'm doing the video simulation for the bug regulator for the subject EEE 3904 Electrical Power Engineering Lab. Before that, let me explain a little bit about the bug regulator. Bug regulators have output voltage that is lower than the input voltage. Okay, so this is the circuit for the bug regulator. The voltage that we set is 13 volt. The value of the resistor is 150 ohms, and the value of the inductor is 18 millihenry. The function of the inductor is to smoothen the output voltage waveform. Okay, these are the periods that we set for the frequency, which is 1/1000 seconds. Okay, let's see the simulation. Okay, the input is 13 volt and the output for this bug regulator is 14.34. This is the output waveform. Okay, this is the output waveform for the bug regulator. Okay, that's all from me. Thank you.
Okay, so for the boost converter of the DC control, this circuit is provided with a pulse generator, series RLC branch, which is the inductor, capacitor, and also the resistor, and it is powered by the DC voltage source. So there is three different variables for the inductor and also three variables for the pulse generator. Other than that, it was all keep constant, which is the capacitor, which is keep it constant to 220 exponentially 6, and also the resistor to 150 ohms. Okay, so for the inductor, it was varied between 0.08, 0.113, and 0.265, and also the pulse generator is varied between 100, 1000, and 110,000. Okay, so the boost converter, and that's all from me. Thank you.
Okay, hi, hello everyone. So this one is the circuit of the buck boost power system. So let me show you. Okay, this one is the power generator. This one is power guidance. This one is the diode. This is MOSFET. This is the DC voltage sources. This one is the RLC branches, and this is scope, and this is display. Let me change it. This is the display, and this is the scope, and it is for the voltage measurement. So you want to see here, just okay. As of first, the DC voltage you put at the 100 amplitude, and then at the power generator I put at the amplitude as 10, 2 in -5 per period per second. The power switch I put it at 20%, because we only focus 20% out of it, because if we focus more than that, we might have been a lot of trouble on looking at the waveforms. And then we just press OK. And for the series RLC branches, this one actually came from the RLC, but then I changed it into the inductor. This one the same thing, but I changed it to the capacitor, and this one is the resistor. Okay, for this one there are 4 types of requirement. The first one is just the 150 ohm. For this case, for the inductor I put it at 0. but in the MATLAB, we are unable to make it to put it at 0, so I put it as like 0. I put it as 1 exponential negative 3, and the capacitor value I put it as constant for every requirement at 47e negative 6. Okay, and then we just run it. By the way, I put it at the simulation stop time is 1. So once we got it, the display are moving right now. It's just like negative 24.19. Okay, so this is the first one. Let's see with the waveform. Then we press this one. This is the waveform that we can see. Maybe just now, if you have seen, it focused on negative 24.19, right? So we just focus on this part, so you can see it clearer. I mean, like what's happening. So you can see the line over here. It's like very straight line. We focus just a little bit more. You can see the line here to go to the right, and this one go to the left, and this one to the right. So let's move on with the second requirement. So the second requirement we focus on 80 milli, right? So I say 80. Sorry, I put 0.08. Okay, then we just run it again. As you can see, the displays are moving. The same thing are going to happen. I mean, the same steps are taken. Okay, the display shows that negative 24.2. We open the scope. We focus on the 24.2. It's over here, right? So let's take a look. Yeah, it's almost there. As you can see in the waveform, it's actually moving from this part to this part, and it's like double layer of the line. So this is it for the second requirement, 150 ohm and also 80 megahertz. Okay, sorry, 80 mH. Next we move on the next one is 0.133, 133, right? So okay, and then yeah, as you can see, the displays are running. Actually, for these 4 requirements, the displays are almost the same, but the kind of the waveform that are produced are a little bit different. So yeah, it's finished. We open this one. We focus on the negative, but I forgot already. Negative 24.2. Okay, this part, as you can see the lines here, right? So this part, this one is like this bit thicker. Okay, what happened on this side? Let's take a look. Oh god. See, you can actually see that, right? Okay, we move on this last one, which is the 0.265, and then we press run. You can see that the display is moving. So okay, there you go. Cool. Okay, here is it. This is the waveform. So you can see that the waveform is like, so you can see the differences, right? Alright, I think that's all for the buck boost systems. So thank you.